Welcome to this presentation on state management with Redux. Today we will explore the fundamentals of using Redux for state management in React applications, particularly in the context of dApps built with Web3.js. By the end of this presentation, you will understand the core concept of Redux, how to integrate it with React, and the best practices for maintaining state in complex applications. So what is Redux? Redux is a powerful state management library for JS applications, especially useful when building complex user interface with React. It provides a predictable state container, making it easier to manage your application state and ensure data consistency across your components. Redux follows three core principles: a single source of truth, state in read only, and changes are made with pure functions. This ensures that your application's state management is predictable, maintainable, and debuggable. So why do we use Redux? Redux offers several advantages for managing state in dApps. First of all, the first advantage is predictable state management. Redux enforces a unidirectional data flow, simplifying debugging and ensuring your dApp state remains constant across all components. Then the second benefit is centralized state. By managing your application state in single centralized store, Redux provides a single source of truth, leading to more organized and scalable code base. Third is the easy debugging. Redux, predictable state management, and unidirectional data flow make it easier to debug your DR, allowing you to track state changes and implement robust error handling. And also there is improved maintainability. Redux separates concerns with distinct actions, reducers, and selectors, keeping your code base organized and maintainable. Let's dive into the core concepts of Redux. First is the store. The Redux store is the centralized hub holding the entire state of your application, serving as the single source of truth. Second is actions. Actions are plain JavaScript objects describing the changes you want to make to your application state, acting as the language between your UI and the Redux store. Third are reducers. Reducers are pure functions specifying how the application states change in response to dispatched actions, ensuring data consistency. And another is a middleware. Middleware allows you to extend Redux with custom functionality such as handling asynchronous actions or logging. To integrate Redux with a React application, you need to install two key packages, Redux and React Redux. The Redux package provides the core functionality of Redux, including the store, actions, and reducers. The React Redux package connects your React components to Redux store and dispatches actions. Run the following command in your project directory to install these packages: npm install redux react redux. To create a Redux store, use the create store function from the Redux package. The store acts as the centralized hub holding the entire state of your React application. Typically, you'll import your root reducer, which combines all the application's reducers, and pass it to the create store function to initialize the store. Here is the example of the code we can use. The first line of the code imports the create store function from the Redux package. The second line imports the root reducer, which combines all the individual reducer in your application. And the last line creates the Redux store using the root reducer. Actions are the fundamental building blocks in Redux, serving as the communication channel between your user interface and the centralized Redux store. Actions are plain JavaScript objects describing the type of action to be performed. This predictable nature ensures that all state changes in your dApp can be easily tracked and understood. Here is the example of the code. This code is really basic, and the first line defines an action create function named increment, and the other line returns an action object with a type property set to increment. Reducers are pure functions specifying how the application state changes in response to dispatched actions. Reducers take the current state and an action as input and return the new updated state, ensuring data consistency. Here is the example of a code. In this code, in the first line declares the initial state of the counter. Then we define the reducer function taking the current state and an action as inputs. Then the switch statement checks the type of action, and then if the action type is increment, the state is updated by incrementing the count. If the action type is not recognized, the current state is returned unchanged. In a complex Redux application, you'll need to manage multiple pieces of state, each with its own set of actions and reducers. Redux provides the combine reducer function, allowing you to combine multiple reducers into a single root reducer. For example, let's say you have a counter reducer and another reducer responsible for handling user authorization. So we can combine these two with the help of this code. In this code, the first line imports the combine reducers function from the Redux package. Then it imports the counter reducer, and then it combines the counter reducer into a single root reducer. Finally, the root reducer is exported for use in creating the store. To make the Redux store available to the entire React application, use the provider component from the React Redux library. The provider component wraps your main app component and passes the Redux store down to all child components. Here is an example of how you would render your React application with the Redux store provided through the provider component. This is a basic code. Let's see this code. The first line imports the provider component from React Redux. It then imports the Redux store, and then the provider component wraps the app component, passing the store to all child components. To connect a React component to the Redux store, use the connect function from the React Redux library. This function maps the Redux state and dispatch actions to the props of your component, enabling it to access and update the centralized state. The example of the code is given. Let's see this code. In this code, the first line imports the connect function from Redux Reacts. Then it imports the increment action reactor creator. Then the next line defines the counter component, taking count and increment as props. Then it displays the current count and dispatches the increment action when clicked. Then it maps the Redux state to count prop, and at the end it connects the counter component to the Redux store. Map state to props maps the state from the Redux store to the props of the React component. Map dispatch to props maps dispatch actions to the props of the React component, allowing it to directly dispatch actions to the Redux store. There are two functions which are map states to props and map dispatch to props. So let's see both of them. The first one is here in this slide. It is const map state to props. This is a basic function that maps the Redux state to the count prop. This slide contains the map dispatch to props. This function basically maps the increment action to the increment prop, and then the final export connects the counter component to the Redux store. Fetching actions is the key to updating the state in Redux provided applications. When a user interacts with your D app, such as clicking a button, it triggers an action to be dispatched to the Redux store. For example, consider the following code snippet where click button dispatches the increment function. This function dispatches the increment action to the store, and then an additional line which is handle increment calls the handle increment function to dispatch the action. You can use that line, handle increment. The use selector and use dispatch hooks from the React Redux library simplify accessing state and dispatching actions in functional React components. These hooks allow you to directly connect your components to the Redux store. The code you can see is very basic here. The first line of the code import reacts, and then it imports the user selector and use dispatch hooks. Then this hook retrieves the count from the Redux state. This hook returns the dispatch functions later, and then finally dispatches the increment action when clicked. Middleware in Redux allows you to extend the default browser of the Redux store and handle more complex actions such as asynchronous operations. Redux Thunk is a popular middleware that enables writing action creators returning a function instead of plain action object. For example, to set up Redux Thunk middleware in your application, you can use the apply middleware function from the Redux library as shown in the code snippet. This code first imports the apply middleware and creates store functions from Redux. Then this imports the Redux Thunk middleware, and then it creates the Redux store and applies the Redux Thunk middleware. Redux Thunk allows writing asynchronous action creators for your Redux powered D app. Thunk action creators can return a function that performs complex asynchronous operations like making API calls before dispatching actions to update the Redux store state. The code example shows here. First, you'll have to import the Axios for this code. So you can do that by import Axios from Axios. Then this code line imports the Axios library from HTTP request. Then it will define an asynchronous action creator named fetch user. Then it makes a asynchronous get request to the API user endpoint. And then finally it dispatches the fetch user success action with the fetched user data. In a Redux application, organize your code into actions, reducers, components, and store configuration. The actions directory houses all action creators, reducers handle core logic, components make up the user interface, and store.js configures the Redux store. This structure ensures a maintainable and scalable code base for your DApp. Redux DevTools extension allows inspecting the state of your Redux-powered DApp in real time, providing a visual timeline of state changes. Logging middleware such as Redux Logger enhances the debugging process by logging actions and state changes to the console. Combining these tools create a robust debugging setup for your DApp. You can use a code which we will discuss later for debugging. To deepen your understanding of Redux, refer to the official Redux document at redux.js.org and the React Redux documentation at reactredux.js.org. Thank you for watching this presentation on state management with Redux. Hope it helped you.